Hello, welcome back. In this segment, I want to show you how to extract proof from Z3. Let us consider this simple program, right? It's not a full complete program, but I wanted to show you a few important things here. Let's say there's a function called foo, which takes an argument x, integer type. And here we are checking whether x mod 2 is equal to 0. If it is true, we get inside y to be x plus 3. And y mod 2 is equal to 0, assert 0. Okay, so for now, I'm going to make an assumption that this integer is same as mathematical integer, not bounded 32-bit integer, just to get across the idea of extracting proof when something is not satisfied. Let's jump into the Z3 model of this. Just focus on x mod 2 equal to 0 and y being x plus 3, and constrain that y mod 2 is equal to 0. Let's talk about that very quickly. So I'm going to now open Python shell and import Z3, and I'm going to set something called proof being true because I want to extract proof from Z3 unsatisfied condition. We need to model the program variable x and y. So I'm going to use mathematical integer rather than bounded integer. Okay, we need two integers x and y, and I'll create a solver object. The first condition I want to add is x mod 2 is equal to 0. And the second condition is that y is same as x plus 3, and the condition is y mod 2 is equal to 0, 0. We can ask Z3 to check. It will say unsat. It makes sense. X mod 2 equal to 0 means x is an even number. If you add 3 to an even number, you get an odd number. Therefore, it's not possible to have odd number mod 2 to be 0 also. Now, we just went through it informally. We can actually ask Z3 to show the proof that this is unsatisfiable. What is the reason Z3 is saying this is unsatisfiable? We can ask the solver to show the proof. We can actually see MP means modus ponens in logic, so we don't have to go through that, all of the details. What did we assert here? We asserted that x mod 2 is 0 and y is equal to x plus 3 with y mod 2 equal to 0. So in the place of y, replaced y by x plus 3. So x plus 3 mod 2 equal to 0 is what we asserted here. But x plus 3 mod 2 is same as x mod 2 plus 3 mod 2 mod 2, right? That's what Z3 came up with in this segment. It's saying, I will rewrite this expression x plus 3 mod 2 as same as 3 mod 2 plus x mod 2 mod 2. It does also know that 3 mod 2 is nothing but 1, as you can see. So it's replacing this whole thing by 1 plus x mod 2 mod 2 over here. And then, so we are making an assertion that 1 plus x mod 2 is equal to 0, right? That's the second assertion we have in this place. Now we can go back to the first assertion we made, x mod 2 is equal to 0. That means we can clearly see this will be 0 because the first assertion said x mod 2 is equal to 0. We can replace this portion by 1 mod 2, which is nothing but 1. Obviously, this whole thing becomes 1. 1 equal to 0 is false. That's exactly what Z3 is saying. It replaced the whole thing by 1, and eventually it came up with 1 equal to 0, which is clearly false. Z3 used this kind of mathematical reasoning, applied the properties of math and also logic to come to the conclusion that it's not possible to satisfy this particular constraint. You have x mod 2 is equal to 0, y is x plus 3. You're also saying y mod 2 is equal to 0. So it was able to say, no, I can't do it. And here's the proof. Your statements are contradictory to each other. That's the reason why it was able to deduct a proof that 1 equal to 0, which is clearly false, and it concluded. So the idea is, if you set the param to be proof true, you can ask the solver to show you a proof. That's exactly what I just did. That's all. Thank you very much for your attention.